Welcome and hello. This is a video tutorial on HEC DSSVue, and in this lesson, I'm going to be discussing map functions. All right, what I have on the screen here is my HEC DSSVue. I have a DSS file opened up with a few different data records here, data sets. There is, let me just describe them real quick before we get started. The first one is flow rate, an hourly flow rate for 5 days. Below that is a time series data, which is an elevation capacity curve. And then the last one is precipitation data. Okay, let's go ahead and just take a quick peek at this first record here. What this is the flow rate from Folsom Lake. So it's an hourly flow rate in CFS, and it is over 5 days here. So the flow rate appears to range from about 2,700 CFS up to 7,800 CFS approximately. All right, so that's our data. Now to perform some math functions, we're going to go up to tools and then math functions. Now I have this flow rate record highlighted, which means that's the file that's selected here. Here's the main math functions box. It's got some tools to it. There's item menus, there's tool buttons. They kind of do the same thing because file, save, and save as are the same as these buttons, save and save as. And then edit, nothing, display, tabulate, plot, and tabulate in Excel. Those are these three buttons here, tabulate, plot, and then in Excel. And then below that is our selected data set. So we can select a different data set. If I had selected all three here, for instance, and went tools, math functions, then we would see those three to select from. So let me just keep things simple, only select one, tools, math functions. Below the selected data set is tabs, which sort of organize and categorize the different math functions available in DSSVue. We have arithmetic, general, time functions, hydrologic, smoothing, and statistics. So once we select one of these tabs, below that is an operator that includes different functions associated with that tab title. So for arithmetic, we have add, subtract, multiply, divide, exponent, absolute value, square root, and so on. There's a bunch of arithmetic related functions there. I mean, these are trigonometry, but it's like close enough. Under general, then we have some general, I would say map functions that are categorized as general. And then under time functions, there's time related functions. Under hydrologic, there's hydrologic functions. So that's just the way to kind of organize the functions in such a way we don't have a drop down with 100 items and it's hard to find what you're looking for. Then we have to start talking about some actual examples. So let's get into our first example here. We had that flow rate, right? Let's go ahead and add. We're going to add either a constant value to the data set or add the value from a time series. Now this is the same time series. So if I just click add and added the same thing, then it would be adding this, it would be just be doubling the value. We can do that. Let's go ahead and do something simpler. Let's just add a constant value of 1000 CFS. So I typed in 1000 here for the value and then click compute. The compute is complete. It tells me down here in the message box. So if I wanted to view those values, I could just click this plot button. And sure enough, we have a plot that now shows the values ranging from about 3,700 CFS to 8,800 CFS. If I want to see the original values, I'll click display and then original data with computed and then click the table, the plot button. And here we have the before in red, which is the original, and then the green is the computed value, which is what 1000 CFS higher. So for whatever reason, if you need to add a certain constant value to your time series values, that's how you do it. It's not actually added yet. It's not saved, excuse me. What I'd have to do is click save. Now, if I click save, it would overwrite, but save as would actually allow me to define the time series, the file name. So it's a separate data set. So that would also be save as. It's a little bit different icon. So let's do that. Let's just go ahead and click save as. And what I'm going to do is instead of original, I'm just going to say plus 1000, and then click OK. The record's saved. Let me close that. Now we have a new record here at the top that says flow, but the part F is plus 1000. So I have the original still, the original data set, and then the plus 1000. And I can again plot those here and see the same thing. All right. So I'm going to go ahead and actually delete that because we don't need that. Okay. And then tool squeeze, and it's actually deleted now. Let's go ahead and do a couple more operations on this data set. Let's go tools, math function, and instead of adding, let's multiply. And again, by a constant value, we'll say 1.5, and then compute. If we want to look at that data, it's just going to be 1.5 times as much. So those are the two records. We can also look at the tabular data. And because I'm looking at the original and the computed, I have two different rows here, which shows those values. All right. Again, it's not saved yet, but I'm actually going to save it. And then as before in part F, I'm just going to say times 1.5 and then click OK. And then it's saved back here. You can see the original and the 1.5. All right, let's go ahead and add a time series to a time series. That's the other function that we have here. Instead of constant, we could say data set. And this is the same data set. So what we're doing is just adding this data set to itself. Oops, I got 1.5 selected. I want to select original, tools, math. Okay, so here's the original selected, and then here's the 1.5. We're just going to add it to itself, and which is basically the same thing as multiplying it by 2 or doubling it. And then I'm going to click compute. The compute is completed. We could view those two records, and then I'm going to go ahead and save as. I'm just going to say times 2. Okay. The record is saved, and now we have the original 1.5 and then times 2. So if I want to plot all three of those at the same time, for some reason, this is what that would look like. I could also display the data, and each data set would have its own column of values, which represent the flow rate in CFS. The next option down, the next data set down here that I had stored originally is paired data. If I click math and then paired data, I can perform the same operations under the arithmetic tab. Some of the tabs are grayed out for paired data just because of the nature of the data and those particular functions. But yeah, I can add values. I can multiply. The last data set that I wanted to explore here was with the precipitation. Let's take a quick peek at this data. This is daily rainfall and for the last 3 months of 2021. And this is measured at the Sacramento airport. All right, the math function I want to perform on this data is in arithmetic still. And if I select the square root, it is accumulation. So what we saw was the incremental, but if I wanted like a cumulative plot, then I don't have to, like this accumulation function is built into place. There's no other parameters. It just works off the precipitation data set. So if I go ahead and click compute, it has computed. And then if I display the original and then plot it, the original here is cyan, and then the computed, which is the accumulated, is in this darker blue color. So you can see we had a storm here on the 24th of October, and then the second, looks like the second week of December, we had a second storm, and then so that computed value is the accumulation. What I want to do here is click save, and then that was, yeah, it came from CDEC. I could just say CDEC and then maybe accumulated. So it saves as a separate record. It said okay, and now I have those two data sets. Here's the original, which is just the hourly, and then here is the cumulative, and I can again plot those values which we saw before. Looks like the color switched, and then also see those values in a tabular format here as well. That's my quick introduction video on math functions. There are a few situations where the math function will compute and result in missing data or no data. So for instance, if if you're performing a function that requires two data points in the two different data sets, and one of those values is missing, then it would just return missing. It wouldn't have a value. Also, if, like, for instance, if you perform the inverse function and you have a value of 0, then 1 over 0 is undefined. So that would result in a missing data. Or also, there's some trig functions here. So if you compute the tangent, but the cosine is 0, that's also dividing by 0. So there are some situations where you kind of have to be careful about your data and making sure you're not trying to ask HEC DSSVue something that it can't possibly do. It could result in some bad data. All right, so that was my introduction to HEC DSSVue math functions.